Okay, in this video we will talk about dot products. This is another part of our unit on vectors. This is vectors part 7, and this is in section 6.4 in the textbook. All right, the dot product is another kind of multiplication that you can do with vectors. We saw scalar multiplication earlier where you multiply a real number, which is called a scalar, times a vector. This is a product that uses two vectors. So here's your actual definition. The dot product of vector u and vector v is written where you put a little dot in between them, and you multiply the horizontal components of each together, and you multiply the vertical of each vector together, and then you add those amounts. So for example, and it's important to realize that the result you will get will be a scalar. It'll be a real number. It's not going to be another vector. All right, so for example, let's say you're going to do the dot product of this vector with components 4, 5, and this other vector with components 2, 3. So the dot product, you're going to multiply 4 and 2 together, and then add to that what you get when you multiply 5 and 3 together. And so then that'll be 8 plus 15, and we will get 23. That will be the dot product. So like I said, you get a scalar, which means a real number. All right, it could be positive or negative, or you could actually get 0. Let's look what happens if you take one vector and do its dot product with itself. So v dot v. So we would do, in this case, we're going to use -2, 6 as our vector. Could be any vector. I just picked a random one. And in this case, it would be multiplying -6 times -6 plus 2 times 2. So basically, you're squaring -6, which is the horizontal component, adding to that the square of the vertical component, right? And that should look a little familiar to you. That's part of what you do when you're finding the magnitude of a vector, right? Now, in this particular case, it would work out to be 36 plus 4, and the dot product would equal 40, all right? If you do the magnitude of the vector, that would be the square root of -6 squared plus 2 squared, or the square root of 40. Okay, so this just leads you to one property that we'll mention. There's many properties, but we'll just mention this one, that if you do a vector dot itself, that's the same thing as its magnitude squared. Okay, an area where you use the dot product is finding the angle between two vectors. All right, now we are restricting ourselves to measuring the angle between 0 and pi radians, or if you're doing degrees, 0 and 180 degrees. Normally I would do the proof of this that uses the law of cosines, but we'll just go straight to how it works. All right, so if you have two vectors and you want to find the angle in between them, this formula will be true. That the cosine of the angle between them, in this case cosine of theta, it'll be equal to the dot product of the two vectors divided by the product of their magnitudes. Okay, so let's just do an example with numbers. Okay, find the angle between, and here are two random vectors. 2, -3, and -4, 3. Okay, so you'll need 3 things to start off with. You'll need to find the dot product of the two vectors. So here's where I work that out. 2 times -4 plus -3 times +3, and that works out to be -17. And you'll need the magnitude of each individual vector. So the magnitude of vector u is the square root of 2 squared plus -3 squared, which works out to be the square root of 13. and also the magnitude of vector v, and that works out to be 5. So if we use the formula that we were just discussing, the cosine of the angle between them is equal to, you'll have the dot product on the top, so that's the -17, and then divided by the product of the two magnitudes. Okay, now in order to figure out theta, you're going to need to use the inverse cosine. So you'll be doing the inverse cosine of that expression. Now, if you remember how inverse cosine works, it always returns an angle between 0 and pi, if you're in radians, or if you have it in degrees, between 0 degrees and 180 degrees, which is perfect because that's what we want. So you can put that in the calculator, and no matter what kind of number this is, positive or negative or even 0, it will automatically give you the right size. It will give you the right angle. So in radians, this one works out to be 2.8 radians. In degrees, it works out to be 161 degrees. Okay. If you do end up with trying to solve one where it's 0, right, the inverse cosine of 0, that will lead you to 90 degrees, all right? Which leads us to the last topic mentioned, and that is what we call orthogonal vectors. Okay, so here's the definition of orthogonal vectors. Two vectors are orthogonal, which basically means perpendicular, if and only if their dot product is equal to 0. All right, so two vectors, vector u and vector v, are orthogonal if and only if their dot product equals 0. Okay, so if you have two vectors and you want to decide whether they're perpendicular or orthogonal, all you have to do is check the dot product. So it works out kind of nicely. So let's say we have these two vectors right here. Right? If I do the dot product, u dot v, I'll be doing 2 times 3 plus -3 times 2. And then that's going to be 6 plus -6. And that does equal 0. All right? So these two are orthogonal. And then here's another example. And if you do this dot product, you're multiplying -7 times +7 plus -3 times +3. That is not going to work out to be 0. -49 plus -9, that will give you -58. So these vectors are not orthogonal.